All right, so this is the next section in lesson 5 about visceral adiposity and insulin resistance. And visceral adiposity is the fat that's stored around our organs, not to be confused with subcutaneous fat, which is underneath the skin. So we're going to talk about how visceral adiposity, why it's so bad for us in terms of increased disease risk. We're going to start off here with a video that gives an overview, and then we'll talk more about it.
A lean belly leads to a healthier, longer life. So when we measure around our waist, we're really measuring this gelatin fat. You see how closely packed together the organs are here? You need that amount of fat. That's healthy. But over here, this is unfortunately what a lot of us are dealing with. All that excess fat surrounds.
So what this is trying to show here is that these peaches are supposed to represent our organs, and then the space in between is supposed to represent the visceral fat. So the idea here is that visceral fat is the fat that's around our organs, and it's going to lead to a number of diseases, as we'll see in just a moment.
Organs are separated by basically this toxic goop. I call it an alien invader. And I want to talk to everyone a little bit about what's happening inside your abdomen and why having a lean belly is such a key to good health. So you're walking around with too much abdominal fat. This fat you're looking at is visceral fat. It doesn't just sit there. It truly is toxic goop encircling all of your organs. It's increasing inflammation. It actually secretes chemicals that increase inflammation throughout your body. But it also affects your cardiovascular system. It increases over time your blood pressure, amongst other things. And as all these parameters are changing, your abdomen, that visceral belly fat, is doing other things. It's increasing production of something called interleukin-6. This chemical further increases inflammation throughout your body. And as this happens, something else really interesting is occurring. Your metabolism is being governed by this excess body fat. Adiponectin is affected. And what does it do when you don't have enough of it? It tells you to store more belly fat. So it's a vicious cycle to poor health. Your liver is overwhelmed with cholesterol. Well, what does that lead to? Plaque buildup in your arteries. And when you get plaque buildup, what happens next? Oftentimes, I see you in the ER, fatal heart attack, and everyone always says, what could I have done differently? Well, the answer is right here now, you've got to target excess belly fat. Belly fat leads to heart disease, cancer, stroke, arthritis, type 2 diabetes, even sexual dysfunction. And I don't want everyone to have to deal with that. Well, what happens if you actually get rid of belly fat and develop a leaner belly? You know what? Studies show you'll actually be smarter. You'll sleep better. Sounds good to me. You'll have a healthier heart. Better sex. They look pretty happy, don't they? Even more money. Less money spent on medical bills, more money to travel the world. Sounds pretty good, right?
All right, so that was the overview of the visceral fat. Now we'll move on to the rest of the lesson. So this is a picture using an MRI or MRS, magnetic resonance spectroscopy, and to measure the amount of visceral fat. And the scan is usually down in your lower back, L4, L5. And what you see here from the image is this very white yellow, very bright yellow here. This very bright white is indicative of visceral adiposity. So this very bright white is the visceral adiposity around your organs. Here is the spine. Here's your belly button. And this darker area here is the subcutaneous fat, or the fat that's directly underneath the skin. Well, way to associate visceral fat with measures that you can do in the field is using the waist circumference, for example. Here we have visceral adiposity, and here is the waist circumference. Generally speaking, as waist circumference increases, so does visceral adiposity. So you're working with a client out in the field, and you measure their waist circumference. The larger their waist, the greater their potential to have visceral adiposity. And what is the cutoff for waist? For males, anything greater than 40 inches, and for females, anything greater than 35 inches in terms of the waist circumference. So anything greater than 40 in men, 35 in women is indicative that they have most likely a high amount of visceral adiposity. Here's just another slide depicting the fat mass and its association with visceral adiposity. So both men and women, as fat mass increases, so does visceral adiposity. So you're working with a client who has a large amount of fat mass. That would be an indication, most likely, that they have a large amount of visceral adiposity. Interesting to note that individuals with the same amount of total body fat, but with low and high levels of visceral adiposity, is depicted here. So you have individuals, here's an individual with the same amount of fat mass as the same individual here. Their BMIs are the same, however, their visceral adiposity is quite different. And the reason for that potentially is where they're storing the fat. Most likely this individual is storing a lot of their adiposity around their waist, whereas this individual may be storing a lot of their adiposity around their hips. And here's a good threshold value for visceral adiposity, about 100 square centimeters. And we're going to talk about in just a minute about where you store fat could have a much different effect on cardiovascular and other disease risk. So why is visceral fat so bad for us? Well, again, it's around the organs, and when it starts to break down, it gets deposited into the portal vein, and the portal vein leads directly to the liver, and that's going to start to impact the liver by increasing the amount of triglycerides that are stored in the liver, and it starts to affect the insulin signaling cascade of the liver, as we learned previously in lesson 5 about how that can lead to insulin resistance of the liver and potentially increase in hepatic glucose production. Any unused fat, the visceral fat that flows through the liver, is going to now make its way to the heart and to the other tissues of the body, causing potential insulin resistance in those tissues as well. Well, our body tries to combat the increased amount of visceral adiposity, but that can have profound negative effects for us. Here's a lean adipose tissue versus obese adipose tissue. Both of these, again, are visceral adiposity. But what you see here in these green dots is the macrophages from our immune system. And the idea is visceral adiposity, as it increases in size, some are going to undergo apoptosis and lipolysis. In other words, they're going to start to be broken down by the macrophages from our immune system. These processes that lead to invasion of the macrophage into the visceral adiposity, however, can phagocytose or devour the dead fat cells. That seems great. However, the problem when you have too much visceral adiposity, these excess macrophages can cause the visceral adiposity to secrete hormones and cytokines into the circulation to invade organs, leading to disease. So in other words, it's an example as our visceral adiposity increases in our body, our macrophages of our immune system tries to attack it to decrease it, to decrease the inflammation. However, it works against us if there's too many macrophages interacting with the visceral adiposity, because that then triggers the visceral adiposity to release excess cytokines and hormones that then circulate throughout the rest of the body, causing damage to the tissue. So again, here's an example of why visceral fat is so bad, because it has inflammatory agents known as cytokines that can contribute to systemic inflammation. It also produces angiotensin that is found in vasoconstriction, leading to hypertension and damage to the microvasculature that can lead to a number of the damages to the capillaries, leading to the various apathies that we've talked about, retinopathy, neuropathy, and nephropathy. Here's another thing, even small increases in visceral fat can result in damage to the endothelial layer, that lining of our blood vessels that is important for gas exchange and nutrient exchange between the blood and the rest of the tissue. So here's a video that talks about belly fat and disease risk. right, so this is the video that talks about the association between belly fat and um, disease risk.
Not all fat is created equal. Belly fat that gives your waistline an apple shape brings a higher risk of heart attacks than having a pear shape. Obesity researcher Daniel Eitzman says it's tricky to tease out why, because people with excess belly fat often have other risk factors like high cholesterol or diabetes. But using mice, he and his team at the University of Michigan were able to control those factors.
The study demonstrates a direct effect of belly fat on heart disease, and this effect occurs without changes in diabetes or blood cholesterol.
Using mice that have no diabetes or high cholesterol but are still prone to heart artery blockages, the researchers implanted different kinds of fat from other mice. When they looked at the transplant several months later, they found fat cells had become inflamed only in mice that received belly fat.
Inflammation in these transplanted fat pads looked very similar to the type of inflammation that is seen in humans with obesity.
As they wrote in the journal Circulation, those mice also developed blockages much more quickly. When they gave the mice a drug known to reduce inflammation, it also reduced the blockages. Eitzman says studying this process will help develop specific drugs to fight heart disease associated with belly fat. In the meantime, he says it's yet another reason to get rid of that gut. I'm Brad Closen.
So what this video was trying to demonstrate is they took the mice that had belly fat and transplanted it into mice who did not. And those mice who had the transplanted visceral fat ended up increasing their disease risk simply because, as this study associates, because of the increase in visceral adiposity, showing that visceral adiposity in and of itself can cause disease, at least in mice, but it's associated with also in humans. This slide depicts the association of visceral adiposity and the various target tissues outlined here. The causes of what happens, in other words, what visceral adiposity will cause to increase or secrete by the visceral adiposity, and then what is the result of that on the target tissue. So for example, we have on the blood vasculature, so the blood vessels, it increases PAI1, which is the plasminogen activator inhibitor used in blood clotting, increased adipokines, which are the cytokines released by the visceral adiposity, increased free fatty acids, and a decrease in adiponectin, so that hormone that's then linked to decreased in cardiovascular disease. Well, all of these being released by the visceral adiposity is going to cause an increase in endothelial dysfunction, which basically means a destruction of the blood vessels, those microvasculature capillaries that can lead to then the diseases of the body. You have an increase in adipokines that affect the red blood cells, that increase monocyte inflammatory gene expression, increase adipokines and free fatty acids, and the remaining tissues of the liver, skeletal muscle, heart, pancreas. All of these can lead to, in the liver, non-alcoholic steatohepatitis, which is inflammation of the liver. In the skeletal muscle, insulin resistance. In the heart, cardiac insulin resistance. Also fibrosis or scar tissue of the heart, left ventricular hypertrophy, which can affect the pumping of the heart, and also diastolic dysfunction, which means the rest of the heart can be affected, puts extra strain on the heart. These can also affect the pancreas in that it causes an increase in beta cell apoptosis or cell death of the beta cell. And finally, adipokines from the visceral adiposity has been linked to an increase in Alzheimer's disease. So the point of all this is that visceral adiposity can have profound effects throughout our body. And it's important that we target this through proper diet and exercise that can reduce the buildup of visceral adiposity, or it can result in a number of comorbidities. So make sure you have a good understanding of this slide about what is the target tissue and what is caused, what visceral adiposity, how it affects it. Here's the visceral adiposity in a normal individual or healthy weight individual and a type 2 diabetic. You can see that there's not nearly as much as that bright white fat in the normal individual, so that indicates less visceral adiposity, versus someone here who's a type 2 diabetic who has a lot of bright white visceral adiposity showing up on the scan, indicating that that individual who's type 2 diabetic has a large amount of visceral adiposity, indicating that visceral adiposity is associated with type 2 diabetes. Here's just another slide indicating that it's an independent, visceral adiposity is an independent predictor of mortality, at least in men, showing here's an individual who has a low amount of visceral adiposity or lower amount of visceral adiposity versus someone who has about twice as much visceral adiposity, and they've increased their mortality risk. Again, just showing the association between increased visceral adiposity and disease risk. This is a very interesting slide that talks about the storage of fat. So moving a little bit away from visceral adiposity, but talking more about this fat in general, where it's stored and how that can have a profound effect on our disease risk. So you have subcutaneous adipose tissue might act as a metabolic sink, protecting various organs against the damage of excessive lipid accumulation and macrophage infiltration. So what does that mean? That means here we have an individual who stores their fat in their hips versus someone who stores their fat in their upper body, so their waist. And so you have excess energy intake. This is going to have, the question is, do you have enough insulin secrete sensitive subcutaneous fat cells to clear plasma lipids and to store energy in adipose tissue? So what does that mean is that individuals who store their fat in their waist or in their hips, that fat tends to act like a metabolic sink to soak up excess fatty acids and triglycerides, keeping them out of the circulation. However, individuals who store their fat in their upper body, that fat in the waist doesn't seem to act like that metabolic sink, soaking up that excess fat and triglycerides. Instead, they stay in the circulation and they have to go somewhere. So individuals who store their fat in their upper body, they lack subcutaneous adipose tissue, and they have markedly hypertrophied insulin-resistant subcutaneous adipose tissue, and they're markedly obese patients. So in other words, they don't have that tissue in their hips that tend to act like that metabolic sink to soak up the excess triglycerides and fatty acids. So those have to go somewhere. As a result, they go throughout the rest of the body, and what happens is they can cause an increased disease risk. Contrast that to someone who stores their fat in their hips. Well, this fat acts like a metabolic sink by sucking up the excess triglycerides and fatty acids out of the blood and keeping them in the subcutaneous fat of the hips, and that allows that individual to have a more normal metabolic risk profile. Well, between men and women, you'll notice that women in general tend to store their fat in their hips, whereas men tend to store their fat in their waist. It's one reason why women tend to have a more protective ability against cardiovascular disease, because of their storage of their fat in their hips that acts more like a metabolic sink to soak up the excess triglycerides, versus the men who lack this subcutaneous fat to soak up excess triglycerides. So this is just an indication that our subcutaneous fat, where it is stored, whether it's upper body or lower body, can have profound effects on one's health. Here's an example of how you can have a normal weight but viscerally obese individual. So here's a normal, how weight loss can have a profound effect on reducing visceral adiposity. Even moderate weight loss of just 5 to 10% with diet and exercise can reduce visceral fat by 30%, which can have improved the risk profile of the individual. So again, looking at just, they had a smaller waist as well. So using your waist can have a profound effect on one's health. So again, measuring the waist circumference can then translate to measuring a lower amount of visceral adiposity. So diet and exercise is very important in reducing overall risk for an individual. So when you're working with a client, focus on diet, exercise, weight loss, and that can have profound effects on reducing visceral adiposity in the individual. All right, so this concludes the section on visceral adiposity. Make sure you just review this, making sure, again, you have a good understanding before we move now on to the next section.